everyone. Hello. I hope all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft. And now in this video, we are going to start our discussion and talk about the different operations that can be performed on a process. So far, we talked about what a process is, right? And what process control block is, what are the different states of a process. But now we'll take our discussion forward and talk about what are the different operations that can be performed on a process. Two major operations that can be performed is a process creation and the process termination. First, we'll talk about the process of creation and then we'll move on and talk about the process of termination. So, what happens is through appropriate system calls, so there is a fork call or a spawn call using a parent process, we can create child process or sub processes. Okay, the process which creates other process is known as the parent process, and the processes which are created, the sub processes, are known as children processes. That is why it says that parent process create children process, which in turn can create other processes, forming a tree structure of processes. So you start with one process, it can create three processes, and those three processes can also create processes, sub processes of its own. Hence, it creates a tree-like structure over here. Remember, each process is given a unique identifier, right, known as a process ID. Okay. And you remember, we discussed in process control block part as well that for every process, we store its process ID as well as its parent process ID as well. Okay, and hence using this, we can create a lot of child processes and a tree-like structure is formed. Okay. Now the next thing that comes in, that whenever you create child process from a parent process, what happens to the concept of resources sharing? Because now if you have a child process, for executing that child process also, you will require some resources. So how does that entire process work? So for the concept of resource sharing, there are three possibilities that can happen. A parent and a child can actually share all the resources. So whatever resources the parent has, the child can also access all those resources. That's one situation. The other situation based on the use case always is that the child process does not get all the parent resources, but it shares a subset of parents' resources. And the third possibility is that the parent and child share no resources at all. Okay. So how does it happen? It basically happens based on the systems implementation. A child process may receive no resources, some resources, or all the resources or with its parent based on the system implementation. Now, to actually prevent the situation of runaway children, where the children is taking all the resources of the parent, right, and the parent is getting nothing at all. Okay, so to prevent the runaway children from consuming all of a certain resource, child processes usually should be limited, right, to a subset of resources which was originally allocated to the parent. If it is the situation where the child is actually accessing a lot of parent all of parent resources, that's like a runaway situation where the parent is left with nothing at all. So usually we should create a situation which is situation number 2, where a child has limited and a subset access to the parent, which to the resources originally allocated to the parent. Okay, so that's one thing. Now, whenever a parent process is basically creating a child process, there are two, I think, options that can basically takes place after the child process has been created. First is that the parent and the children process both are executing concurrently. That means both are executing together. Okay, so in this case, the parent and the child run concurrently with each other. Okay, and they continue to complete their execution without waiting for anything else. Okay, now it is also possible that for a parent to run for a while and then wait for the child later, which can occur in a parallelism sort of a scenario, but usually parent and child can execute concurrently. That's one situation. The other situation is that the parent actually waits for the child to terminate first, the child process to terminate first, and then it completes its execution. So in the second situation, parent basically makes a wait system call. So we have a wait system call wherein we actually expect the specific child process to complete its execution. Until that time, the parent process is basically blocked. Okay. And once the children process is completed, then we can restart the process of the parent process over here. Okay, that's what the overall idea is when we talk about the parent and the child processes and how their execution will happen. Now, the next thing is in terms of Unix operating system, right? Each process we already know has a unique process identifier, right, which is a unique integer. Now, using a fork system call, right, we can create a new process from the original parent process. The new process basically has a copy of the address space of the original process. That means we know that the child process basically keeps the process ID and the address space of the parent process. And using this, because we are storing the address space of the parent process, it's quite easy for the parent process to communicate with the child process. So the communication process becomes very easy. Okay. Next is the EXEC, which is execute system call, which is used after the fork call to replace the process's memory space with a new program. Okay, so this call, what it basically used is, we actually use it after the fork system to call by one of the two processes to replace the space. So either you can use this particular call either on the parent process or on the child process. Okay, what this call basically does, it loads a binary file into the memory and destroying the memory image of the program that actually contained that system call. Okay, and then it basically starts its execution. So in this manner, the two programs are able to communicate with each other and then they simply go their separate ways. So in the Unix operating system world, this is how you create a child process from the parent process. Okay. Next, we will talk about the concept of process termination. Let's say the parent process is executing and the child process is also there. Now, by making a exit system call, okay, so wait system call is when parent is waiting for the child. Okay, fork system call is using the like I would say the parent, you're creating the child. Then we have a wait system call. In wait system call, it basically returns us an integer value where processes request their own termination. Okay, so the process can execute their last statement and then ask the operating system to decide their exit and decide their termination using the exit system call. Okay. Now, the process may also be terminated by the system also for a variety of other for a variety of other, I would say, reasons as well. So it's not like only when the process will end, only then when it has executed its last statement will it ask for its termination. Okay, there are a lot of other reasons as well. Okay, so what happens is sometimes there is an inability of the system to deliver the relevant system resources. Sometimes there is a process which requires some resources, but the system is actually incapable of providing those resources. Okay, so in that case, what happens is we basically terminate a process. In that case, also termination happens. Okay. There is also a kill command, okay, which basically also terminates a process as well in case of unhandled process interrupt. So we know interrupt happens because when we forcibly take the resources of a CPU, right? In that case, sometimes we use a kill command also to terminate the process altogether. Okay. Sometimes it may also happen that a process may kill its children, okay, if the task that was assigned to the child is no longer required. Okay, sometimes what happens is you created a sub process, a child process, because it had to do some task, but now you no longer need that task altogether, right? You no longer need to do it. In that case also, you can terminate the child. Okay. Also, in this point, like we talked about, parents' resources are deallocated by the operating system, right? Parent may execute. So there are two things: the process resources, the parent process resources, or the child process resources. Sometimes get deallocated in terms of a situations of an interrupt or a kill command. In that case, also a process interrupts. Okay, and sometimes the parent may terminate the execution of a child process as well. Okay, and sometimes what happens is there is a parent process, there is a child process. The parent process is exiting. Okay, and because of which we may or may not want to allow the child process to execute without a parent. Okay, so it's like an orphan, I would say, process over here, wherein your parent is exiting but the child is still there. In those situations also we terminate sometimes the child process as well. Okay, always remember that whenever a process ends, all of its resources are freed up of open files which are there. They are flushed out and they are closed. Okay, the process termination status and execution times are returned to the parent if there is a parent which is waiting to execute. Let's say you have a parent, you have a child. The child basically terminates. So all of its termination status, its execution time is returned to the parent, so that if parent was waiting for the child to complete, then it can go ahead and move forward. Okay, so that is why we use it as well. And the processes which are trying to terminate, right, but they cannot do so, right? There's a process which is trying to terminate, but it cannot do so because their parent is waiting for them. They are known as zombie processes. Okay, they are usually inherited as orphans then, and then they are killed off. Okay, so remember, there is not only one situation in which we terminate a process, there can be multiple situations that can exist. Okay, so this pretty much is a small discussion about how do we do operations on processes. Okay, we create a process using a fork system call. We have a parent process. We can create a lot of child process, forming a tree-like structure. We can share all the resources between parent and child, some resources or no resources at all as well. Okay, in terms of execution also, we have two options: either both execute parallelly, or the child or the parent waits for the child to execute first and then it continues its execution after that. In a Unix world, we basically use fork system calls to create new processes, and execute system call is used after the fork system call to replace the process memory space, because now it has been created and processed, and to load a new program into the memory. Then we have process termination, wherein we terminate a parent or a process either because it has been fully executed, or because it was a child process which is no longer required, or somehow a interrupt happened, right? And because of a kill command, the process has been removed, or a parent is exiting but the child is still remaining and we do not want an orphan process to happen. So in that case also we terminate. Okay, and sometimes we created a child for some purpose, but that purpose is not required altogether anymore. So in all these situations, we do take care of process termination. All right, and this completes our entire discussion about the concept of operations on processes. In the next video, we are going to talk about the classification of processes into two types. So we can classify them as independent processes, and we can also classify them as cooperative processes. Now in the next video, we'll talk about what is the basic definition about that and what are the advantages of having cooperating processes. Okay, so stay tuned in for that video as well. Thank you so much for attending and taking a look at this video. I hope what we all discussed is clear to everyone and makes sense as well in terms of why we are taking a look at this topic and what all we can really do. You don't have to go into detailed implementation for all of these, although if you want, you can refer to some resources on the internet of that. But the basic idea is that you are clear with the overall ways we can create a child and what all happens in terms of a theoretical way of how the child and the parent process operates. Okay, so thank you so much for taking a look at this video. Please go through all the resources and make sure you understand them and learn them as well. Thank you. Bye.